Hello, everybody. Here we are, 1.4 estimating square roots. So first, I just have a little bit of info, a bit of reminder that your calculator can square numbers and calculate square roots. So this button right here, x to the power of 2, is the most common calculator button for squaring a number. And this one right here, this radical, the x in it, is the most common calculator button for taking the square root. So I don't know, I have a calculator on this computer. I have a x squared button right here, so I can go 5 and press the x squared button. And similarly, my square root button is this one right here. Hopefully you can see that. So if I press that, I should go back to 5. There you go. So take a look at your calculator. I think I've talked to most of you, but good to know those two buttons for sure. That one and that one. So let's solve the following using your calculator. Let's do a few. I'll use my calculator here. Let me drag it over so you can see. So I'll go 8 squared, 64. Next one, 11 squared, 121. Next, 16 squared, 256. And now we're going to do some square roots. Let's do 16, and I'll press that radical button. It's going to be 4. Let's do 81 radical, 9. And last, 169 square root, 13. Okay, just a little bit of practice there. So today we're talking about estimating square roots. And I think once you can kind of wrap your head around it, I think you folks will do well. One of the kind of areas of competence that I'm supposed to assess you on is your ability to estimate reasonably. So this is a really helpful tool in math just to know if you're kind of heading in the right direction. So we need to relate the value of the square root to the perfect square. So draw a line with the perfect squares above your number line. Use the number line to estimate the values of the following square roots. So here are our perfect squares: 1, 4, 9, 16, 25. You know, if we went on, 36, 49. And these are their corresponding numbers. So the square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. Square root of 25 is 5. So those all correspond with these like actual numbers. So let's use this information to estimate some square roots. So square root of 6. Well, oops, let me erase this. 4 is right here and 9 is right here. So it's kind of like 4, 5, 6, 7, 8. So the square root of 6 would be about there. Square root of 6. And if we follow this line directly down from there to there, we can estimate the square root of 6 at about, looks like it's a little less than half. You know, we could maybe say, guess like 2.4 or something like that. Okay. Let's see, I can check. I mean, how close am I? I'm not too sure. 6 square root 2.449. Okay, not bad. Not bad. Actually, I guess it would round to 2.4. Let's try the square root of 3. So this would be 1, 2, 3, 4. So 3, square root of 3 is going to be about there, square root of 3. And if we continue this line down, 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 right about here, I'm going to guess it at about, 1.6, maybe 1.66 or 67. Because it's about, they're split into roughly thirds, so that would be about 2/3. I'm going to guess 1.67. Let's find it out. 3 square root 1.73. Okay, not bad. Next, let's try the square root of 12. So say you would have 9, 10, 11, 12, 13, 14, 15. So that would be 10, 11, 12. Looks like right there. square root of 12. And if we follow that all the way down here, it looks like it's just a bit before half. So a little bit less than 3.5. Maybe again, I'm going to do 3.4. And we can see that. I can check 12 square root 3.46. So maybe 3.5 might have been a little bit better if I rounded up, but not bad ultimately. And the next one, 20. Okay, so if we did 16, 17, 18, 19, 20, 21, 22, 23, 24. So 17, 16, 18, 19, 20, about there. Square root of 20. So a little bit before half. Okay, maybe 4 point, I don't know, 39, let's call it. So let's see, square root 20, 4.47. Oh, it's not a great guess. Let me do another one. I was gonna do 4.4 again. Maybe I should do 4.45. Okay, not bad. Pretty close to half. So there you have it. I mean, not exact, I didn't estimate perfectly, but pretty close, right? You can kind of guess the first number for sure, the second number a little bit. So that's basically how you do that. So let's do a few. Use the number line below. Which placements are good estimates of the squares? And let's explain our reasoning. And then we're going to use the number line to estimate the value of each square root that is incorrectly placed. Okay, so let's see. Is this a good estimate, the square root of 27? I think it's, pretty good. The square root of 25, I usually use blue. Why am I using red? Here we go. Good estimates, 27. The square root of 25 is 5. So I think that's a pretty reasonable estimate, actually. It's just a little bit above that. I think that's a pretty good one. Next one, 35. Well, the square root of 6, or the square root of 36 is 6. And now we have 35, and it's above that. So I think that's actually not a very good guess. I'm gonna say not a great guess. Because I think it should be more like right here. Okay, so I think that's not a very great guess. Square root of 49 exactly at 7. That seems perfect, right? I know that 7 times 7 is 49, so I think that's right on the money. Here we have 56 right here. Well, this would be 64. And it's it's going to be closer to 49 than it is to 46. So I would say that's not a great estimate, right? So it's 56 is 8 away from 64, and 56 is 7 away from 49. So I think a better estimate for our 56 would be somewhere like right there. Okay? And then 62, that looks like a pretty good guess. 64 is right here. It's just before that. So I think that's pretty good. Now it wants us to use the number line to estimate the value of each square root that is incorrectly placed. Okay, so let's predict the square root of 35. So not quite 6, but pretty darn close to it. So I'm going to guess like maybe 5.9 is my guess there. So not quite 6, but pretty darn close. And the square root of 56, pretty darn close to half, but a little less. I'm going to guess 7.48 maybe. So let's see. 35 square root 5.91, pretty good. And 56 square root 7.48. Wow, right on the money. So pretty good estimates. There you go. So let's look at number 3. Which two consecutive numbers? Remember we talked about this word a little bit before, consecutive. So coming right after each other, numbers, is each square root between. How do you know? Okay, so what I would think about is our kind of like our celebrity numbers, right? So we have our perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. Hopefully you can see this. 144, 169. Okay, that's tall enough. So if you can think about it, the square root of 9 is 3, and the square root of 16 is 4. And 15 is between 9 and 16. So the square root of 15 is going to be between 3 and 4. And I know that because I situated it between the square root of 9 and the square root of 16. Let's do the next one. And this, again, might be helpful for you to use a number line for this. So let's see, like, if we continued on, I'm gonna go up here. All right, so put your attention up here. I'm gonna keep this number line going. If we had 9 right there, we had 10 right there. 9 would be the square root of 81. 10 would be the square root of 100. So 72 would be between this square root of 64 and the square root of 81. So it's going to be between 8 and 9. You could check this if you'd like. You can go 72 square root, and we should get a number that's between 8 and 9. Okay, there you go, 8.48. Wonderful. What about 110? So it looks like it's above 100, but it's below 121. So it's above 10, but before 11. And you could check this again if you'd like. Let's put it in our calculator. 110 square root. There you go, 10.48. And the last one, 41. If we put this up on our number line, or we put it in this group right here, looks like 41 is going to be between 39 and 36 and 49. So between 6 and 7. And we can check that in our calculator. 41 square root 6.4, which is between 6 and 7. Okay, last we have a question. This one's a little tough. It's going to give us a big number, and it's going to seem really hard to estimate what this square root could be because it's so big. But if we ignore the zeros, that might help our cause. Okay, so let's go. Farmer has 600 meters of fencing. Okay, bought it wholesale. He wants to see if he can go all the way around his field. So he wants to enclose a square field of area 24,200. What are the approximate dimensions of the field? Okay, so he's got a huge field like this. It's 24,200 meters squared. They want to know the dimensions, so they want to know the side lengths. So we want to know approximately what is the square root of 24,200. Okay, give your answer to one decimal place. So what I'm going to do is I am going to, just for a moment, ignore these two zeros. Okay, so just for a moment, I'm going to make this and just pretend this is 242. Now that's much more manageable, okay? Because we have, if I go 15 squared, that's 225. And 16 squared is 256. So our 240 is going to be between those two. Okay, so I can estimate